Hi guys, today we're adding input and changing our script to do a little bit more than just rotate. So this is the project that we have from last time. The only thing we've added was one single sprite whose view is a square of color green, and we've added this rotate script, which is just rotating our sprite like so. Now, if we go to Edit and then Project Preferences, in the Input Manager, you'll find a bunch of things that already exist, which means we're just able to use them as is without making any changes. So we'll do just that. If we open our rotate script, or rather, first of all, let's rename it to something. F2 is rename. We're going to call it sprite script or custom sprite script. How about that? And let's now open this in Visual Studio. If you just double click that, and if you've done everything as needed previously, then that should be fine. Let's rename this to sprite script as well. And how about we move by using input? So we can take input information by using input.something. And that's going to be queried every frame. So in the update, which is called every frame, we can do something like get access, get key, and so on. Let's first try get key, just to make things simple. And then you're able to input key code and then select the actual keyboard key that you want to query. For example, F. And that returns a billion, which means we can add it into an if statement and then have something like this. If input get key code F, that means if F is pressed, then do something. And that is very common across various engines. Certain engines do it slightly differently. They add things like callbacks. So, for example, at the start, some engines may do something like input, add a trigger listener or something. And then you would pass key code F and then some code to run when this F key is triggered. So you can see that the approaches are slightly different, but ultimately they provide you with the same functionality. And we can easily check if the key is being pressed by just logging something like F is pressed. Control S to save and then go back to your Unity ID, and then let's run the game. So it's still doing its own thing, which is that bit. And then if we press F, then you can see that F is pressed in this console, which you can enlarge and see all the F is pressed messages. There are lots of them because typically the update function will be called 60 times a second, or the number of ticks per second, however many ticks you want to get out of your game. Usually it's 60, but modern refresh rate displays, high refresh rate displays get up to 144, 240, even 300, I think, at this point, or 360, something along those lines. And depending on how many frames you want, you will need to update that many frames. Otherwise, you're just rendering at high speed, but not actually doing a lot of stuff internally in terms of the game model. And this is a very important separation between game model and then game view that we will discuss at some point in one of the lectures. Right, so we've done this, and now with just a little if statement, you're able to query a lot of keys to do whatever it is that you want to do. Now let's make this a bit more interesting and actually modify our game in some way. So we can obtain a reference to game object using this, or alternatively you can just call transform directly, so we don't actually have to call game object.transform. If you do this, it'll still access the same transform. Just to check that it's correct, we're going to rerun our game. And it's still rotating. This is a very common workflow to test your changes incrementally. You don't want to add a lot of code and then test, because if something does go wrong, then it's very difficult to debug. Right, how about we use keycode D to move right. So instead of just printing a debug statement, we're going to take transform, we're going to take its position, and we're going to add a new vector. We could add vector 2, but we're going to do it vector 3 because since we've been using vector 3s. So the x-axis is what we want to move, which means 50-ish multiplied by time delta time, and 0, 0 in other axes. Now this is probably a bit weird looking if you're coming from Java, because in Java we don't have operator overloads. If you've used Kotlin or C++, then it's kind of straightforward. Imagine, if you're a Java programmer, imagine you're doing something like this. Position, add, local, and then the new vector thing. That's somewhat equivalent, as in it will result in the same thing. However, here we're actually taking the position and then reusing it to then add to this thing. So this new vector 3 becomes an offset rather than an absolute value. And operator overloads allow you to just write in a more concise, more domain-specific sort of way, which is why certain languages like C# support this. Now let's see if this runs. So that was super fast. You may want to slow it down. 10 maybe is a good value. So if I press D, I now move to the right along the x-axis, along the global x-axis, I should point out, because as this thing rotates, its own local x-axis changes. And so if you do something like transform translate, then you're going to end up with a very different result, which we can also see over here. So in some engines these are equivalent, but you can see that in here it isn't. When we translate, we're actually translating along the sort of local x-axis, because if we didn't, it would have the same result. But depending on what you want to do with your game object, you will pick the appropriate translation. For me, this is more suitable. I want to be able to move left and right, regardless of my rotation. So I'm going to keep this. However, there is a different way of doing something similar, and that's using the pre-built axes that I showed you earlier in project settings. So you have the horizontal axis, and you can see that left, right, A, D sort of key codes have already been entered. So we can just use them as is. And we're effectively mapping sort of virtually. And by that, I mean that we don't actually map to, we don't actually hard code the key like here. We use an abstraction, and that allows us to run the same game, the same input on different platforms, like mobile, for example, where you don't have a keyboard and you don't have things like key code A, key code D. You would use the touch screen to move around, or you might use some kind of virtual joystick, virtual controller, depending on how the UI is laid out. And the thing that we want is x-axis or horizontal axis, and we can do so by calling input get axis horizontal. That returns a float that we can use to enter into this thing. So we don't actually need to check the key anymore. X-axis value just goes in here. Rather, we can multiply by it. So if it's left, then it's minus. If it's right, then it's going to be plus. I don't actually know how large the value is going to be. Yeah, that's not too bad. So I can move left and right by using A and D. And also the arrow keys, because all these things are mapped. Similarly, we can do the vertical axis, which I'm going to call y-axis. And then we can just copy paste this, vertical, and then we can just do something like this, really. Just copy paste this into the y-axis, and then replace x by y, because everything else is the same. I can now move up and down, left and right, and that's sort of rotation independent, regardless of the angle of my game object. I can move around in 2D space relatively easily. One last thing we're going to look at is how to extract these values into the editor, so that we can change the values inside the component over here rather than in code. And that's actually reasonably simple. We can just declare a public variable, say float, call it something like move speed, and then we'll need to use this variable over here somewhere. We're going to just do this, set it to 10 by default, which is what the value was. And then if we go into the editor, select our sprite, which has the custom sprite script component, then we can see the move speed over here. And we should be able to change it to something like 20 for this specific sprite. If I added a different sprite and added another component, then its value is going to be different. So now I'm moving with speed 20. I can change that speed to, say, 60. And then I'm moving much faster. Okay. That should be enough for this session. We've looked at how to use input in code. obtain various axes as well as specific key codes in order to interact with the game. Because without input, you don't really have a game. It's more of a simulation because you're not interacting with it. So input is kind of a big deal in games. And based on that input, we did something to the game. We changed the transform of our game object. Specifically, we changed the position aspect of the transform, which means we moved it in 2D space, or a different term to use is to translate. Translate basically means move. We also added a public variable to our custom script, which allowed us to change this, the value of that variable within the editor over here. And on that note, thanks for watching, and I'll see you guys in the next one.